Welcome back to the Deep Dive. Today, we are plunging into, well, probably the biggest, loudest conversation happening anywhere in tech or finance.
The AI boom.
The AI boom. You've got this incredible hype, just massive spending, and this really big, scary question hanging over everything. Are we in an AI bubble?
And that is the core mission of this deep dive. We've pulled together analysis from, some of the sharpest investors out there, top tech analysts, to really try and cut through the noise.
Right.
We're going to confront what one of our sources called the taboo question.
Which is?
If AI is really the biggest trend we've ever seen, why is the hard economic evidence, the proof, only just starting to show up now?
Okay, let's unpack this then, because the numbers are, they're truly astonishing. To sort of set the macro stage here,
Yeah.
the U.S. is planning to add, an estimated $3 to $4 trillion in data centers?
Over just the next 5 years.
And to put that into perspective for everyone listening, our sources pointed out that this investment in today's dollars, inflation adjusted, is bigger than the entire U.S. interstate highway system.
Which took 40 years to build.
Exactly. So when you hear numbers like that, they just scream bubble, but are they actually justified?
That's where you have to look at history, I think. It's so easy to panic when you hear trillions being thrown around, but the key is understanding the nature of the spending.
Okay, so let's make that comparison. Let's look at the current AI build-out versus, say, the year 2000 telecom bubble. What was the defining thing about that era?
It was defined by one concept, really. Dark fiber.
Dark fiber.
Yeah, fiber optic cable was being laid everywhere. The promise was this future of limitless bandwidth, but it was basically useless unless it was lit up with all the necessary optics and switches.
It was just sitting there.
Just sitting there. And at the peak of all that speculation, our sources confirmed that an astonishing 97% of all the fiber that was laid was dark.
97%. So it was almost all just wasted capital.
Investment poured into capacity that nobody was using. It was pure speculation on future need.
That's a really stark image.
Yeah.
So how does that compare to today's GPU build-out? Is the data telling us it's the opposite?
It's the complete opposite, and this is the key indicator that this time is different. There are no dark GPUs.
None.
None. The equipment being bought, whether it's Nvidia chips or Google's PPUs, it's being fully utilized the second it's plugged in, instantly.
And not just utilized, right. They're being pushed to the absolute limit.
To the point of melting. I mean, you read these technical papers, and one of the biggest problems in training these massive models is that the chips are running so intensely for so long, they're at risk of literally melting.
So this is more like building an essential utility, like a power grid, not a speculative monument.
Exactly. It's necessary infrastructure.
Okay, that's a fascinating metric of use. But what about the return? How do we know the spending is efficient? I'm talking about ROIC, the return on invested capital.
The sources are, frankly, overwhelmingly positive on this. The numbers are historically powerful. When you look at the biggest spenders on these GPUs, remember, we're talking about the biggest public companies in the world.
Right.
They've seen approximately a 10-point increase in their ROIC since they started ramping up this capital spending.
10 points is huge. For companies of that scale, why is that so significant for our listeners?
Well, for a company this big, an increase of 1 or 2 points in ROIC is considered a massive win. A 10-point jump suggests that every single dollar they're putting into this infrastructure is generating superior returns almost immediately.
That is it's virtually unprecedented for this kind of capital deployment.
It's the strongest signal you could ask for that the utility is real, and it's generating real revenue, not just spending for the sake of it.
Okay, ROIC is a critical piece of proof. Let's touch on valuations just briefly to really drive the comparison with 2000 home.
Right. Well, Cisco, the poster child of that bubble, it peaked at, 150 to 180 times its earnings?
Which is
completely insane. Nvidia today is more like 40 times. The whole financial structure is just much, much healthier. And the proof is in the usage data itself. You see it in the fundamental unit of work for these models, the token.
Explain what a token is, quickly.
Think of it as a word fragment. It's a piece of data the AI processes. Well, Google just shared a stat showing a 150 times increase in the tokens processed across their system.
150 times.
In just the last 17 months. So this isn't some theoretical demand. This is real, intense utilization that's driving that ROIC.
Which leads to the question, who is footing this massive bill? And, can they actually afford it if the market turns?
That's where the balance sheets come in. We're talking about the biggest tech companies, the Mag 7. Collectively, these companies generate about $300 billion in free cash flow a year.
300 billion.
Per year. And they hold $500 billion in cash on their balance sheets. So that gives them, an $800 billion buffer.
So their balance sheets are basically the ultimate insurance policy.
Absolutely. It makes all the market fears of a sudden financial pop kind of overblown. I mean, to put their spending in context, lighting up just 1 gigawatt of compute costs around $40 or $50 billion.
And they can fund that out of pocket?
They can fund multiple gigawatts without ever having to raise external money. They have the firepower to drive this for years.
Okay, we have to talk about this controversial idea of round-tripping deals.
Yeah.
Where a chip maker invests in a startup who then immediately buys their chips.
Yeah.
Our sources say this is definitely happening, but maybe not for the reasons people think.
Right. It's happening, but at a very small scale. And the motive is critical. It's 100% driven by competitive dynamics. It's rational.
So it's not about financing these labs.
Not at all. It's about market positioning. You have to understand, Nvidia's biggest competitive threat isn't really AMD or Broadcom. It's the hyperscalers themselves. It's Amazon, and most of all, it's Google.
Because they're building their own chips.
They're building their own entire infrastructure. And Google is a uniquely powerful competitor here because they own DeepMind, they own Gemini, and they own the TPU.
The tensor processing unit.
Exactly. It's their own custom AI chip, and it's arguably the only real alternative to Nvidia for large-scale training today. Google's entire internal AI business runs on TPUs.
So when Google or Amazon go to a lab like Anthropic, they're not just offering cash, they're offering access to their own proprietary chips.
Precisely. They create these captives. Anthropic runs on Google's TPUs or Amazon's Trainiums. So if Google comes to a lab and says, hey, I'll fund you and give you access to our cutting-edge hardware, Nvidia has to respond.
So the round-tripping is a defensive move.
It's a strategic necessity. The mentality is existential. One source mentioned that Larry Page reportedly said internally he'd rather go bankrupt than lose this race. That's the level of pressure we're talking about.
That puts this competition in a completely different light.
Okay, let's pivot from the infrastructure to the application layer. What's happening with the actual products? I love the analogy that we're still in the Netscape Navigator era of AI.
It's a great analogy because it signals humility. I mean, think about the Netscape moment. Google hadn't even been founded. Amazon was just selling books online.
Mark Zuckerberg was in middle school.
Exactly. So making these high-confidence predictions about who wins at the application layer is, well, it's probably foolish.
But do the big guys, the Mag 7, do they have an inherent advantage?
They do, but only if they execute. For them, AI could be a sustaining innovation. They own the data, the capital, the compute, the distribution. They're positioned to win.
Okay.
But failure to execute is an existential threat. Just look at what happened to IBM and previous tech transitions. They have every right to win, but it is not guaranteed.
Let's talk about the business model itself, specifically this pressure on gross margins. For years, the gold standard for a SaaS company was, 80–90% gross margins?
That was the holy grail. Why is AI so structurally different?
It comes down to two big technical ideas, scaling laws and test time compute. Scaling laws basically say that to make a model smarter, you need to throw exponentially more data and compute power at it during training.
Okay, and how does that affect the cost of actually running the product for a customer?
Well, because the models are so huge, every single time a user makes a query or the model processes a token, it burns incredibly expensive compute. That's test time compute.
I see.
So AI products are just inherently more expensive to run than old SaaS platforms. This means gross margins for these AI companies are going to be structurally lower, maybe 60%, maybe even 50%, not 80 or 90.
So the big takeaway for application companies listening to this is, don't be afraid of declining gross margins.
Exactly. The shift away from 80% margins should be seen as a mark of success, not a badge of shame.
Like the cloud transition for Microsoft and Adobe.
A perfect parallel. They took a margin hit to drive adoption. If a company today claims to be AI-driven, but they still have 82% gross margins, the hard analysis says nobody's actually using their expensive AI features.
The lower margin is literal proof that people are getting value from the most expensive part of your product.
It's a measure of true adoption. And, speaking of models, our sources debunked this idea that we've hit the end of scaling laws with GPT-5.
Oh, right.
The reality is that GPT-5 is reportedly a slightly smaller model designed to be more economical for OpenAI and Microsoft to run. It was an efficiency play, not a physical limit.
That relentless need for compute keeps the pressure right on the chip ecosystem, which brings us back to that hardware battle.
It's still primarily a fight between Nvidia and Google's TPU. And what's fascinating is how Nvidia has evolved. They're not just a chip company anymore. They're not even just a software company with CD.
They're a systems company.
They're a total systems company. They provide the whole rack, the networking fabric, the architecture for the whole data center.
Selling the entire kitchen, not just the oven. But there is an attempt to create an open alternative, right?
There is, yeah. Broadcom and AMD are sort of going to market together. They're offering an open Ethernet fabric standard with custom ASICs.
ASICs being application-specific chips.
Right. And the idea is that if your custom chip doesn't work, AMD can plug right in as the fallback. But the prediction from our sources is pretty bleak for most of these custom chip makers.
They're going to fail.
Most will likely fail, especially if the rumors are true and Google decides to start selling its TPUs externally. That would just change the game completely. The battle stays fiercely concentrated.
So what does all this mean for you listening at home or in your car? The biggest shift here isn't just the tech, it's the entire business model. We are moving away from paying for processes and toward paying for outcomes.
Which raises the billion-dollar or trillion-dollar question: how do you price an outcome? We're already seeing the first signals in customer support software. The pricing is shifting to be based on the successful resolution of a task, not just how many agents you have. And on the consumer side, the model moves from advertising to affiliate fees.
Give us a concrete example of that.
Okay, imagine your personal AI agent finds you the perfect flight or hotel room. It knows what you like, your past trips. You don't pay anything. But when you book that room, the AI gets an affiliate fee from the hotel.
It only gets paid for a successful outcome.
For a successful booking. And that fundamentally squeezes out all the waste from the old system.
How so?
Well, historically, advertisers have systematically overpaid on platforms like Google Search because they can't perfectly track value. The AI layer just cuts through that. It moves directly to an outcome-based payment. That's a fundamental change to how value is exchanged online.
Okay, to leave you with one last provocative thought that sort of builds on all this. Look beyond the chips, beyond the models, to the future of work itself. Our sources suggest robotics is now seen as a very real head-to-head fight.
Between Tesla and the Chinese.
Tesla and the Chinese. And the debate over whether humanoids are viable is apparently over.
It seems to be. Because the compute is now so powerful, they can be trained just from watching human demonstrations or even by just watching YouTube videos.
Then the implication of that is staggering.
The power of this tech, if it's realized, means human work. Well, it could become optional. And consider this final point on the AGI timeline.
AGI, artificial general intelligence.
When experts like Andrej Karpathy suggest AGI is maybe 10 years away, our sources noted that inside the industry, that timeline isn't seen as skeptical. It's seen as wildly aggressive and optimistic.
So 10 years is the bull case.
That's the super bull case. So what does that level of confidence combined with this massive build-out we're seeing right now tell you about the next decade? Something to mull over.
We'll catch you next time.